Assalamu alaikum students. Hope you are fine and enjoying these video lectures on AI. In previous lecture we covered breadth first search, and in this video lecture we will cover depth first search, depth first iterative search, iterative deepening search, and all of these three search techniques are belongs to uninformed search techniques. So our major topic is problem solving by search techniques. So here is the some properties of search techniques, which are completeness, optimality, complexity with respect to time, complexity with respect to space. And in our previous lecture we discussed these properties for BFS. In this lecture we will cover these properties for DFS and TF-ID. So here is the example of a tree which we used in previous video for BFS. uh, I will also use this tree for DFS, and we will compare the DFS and BFS by using the same example. So BFS traverse any tree level wise. BFS cover the first level, then second level, then third level, and so on. But the DFS traverse any tree branch wise. So the depth represents the depth branch. So it will traverse the first branch, then second branch, then fourth branch, first branch, and the sub branch. So it will traverse like this. It will traverse A, then B, then D, then E, then C, then F, and then G. And here is the resultant result for this tree by using depth first search. Now I will traverse this tree programmatically. In BFS we used the Q data structure, which is the first in first out data structure. So for depth first search we will use stack data structure, which is LIFO, last in first out. So here is the stack, empty stack, which have no element, and the length of this stack is 4. I will push the root node in this stack. So then I will pop this node and check whether it is a goal or not. If it is a goal, then I will stop over here. Otherwise I will mark the red color over here and place these two child nodes over here. So I will traverse this node, and I write over here, and the children of this node B and C, I push these two nodes over here. So look at the arrangement. I put the C node first, then I push the node B after the C node. Then I will traverse the B node because it is at the top of the stack. Then I will check whether it is a goal or not. If it is not, if it is not a goal, then I will mark the red color over here, and the children of this node D and E, I will put these two nodes over here. And और यहाँ पे देखें कि यहाँ पे स्टैक मल्टीपल नहीं है, ये एक ही स्टैक है और उसी स्टैक के अंदर ये काम हो रहा है. जब मैं पुश कर देता हूँ उसके अंदर एलिमेंट चला जाता है, जब पॉप करता हूँ तो उसमें से निकाल के हम चेक कर लेते हैं क्या है कि ये गोल है या नहीं है. सो देन आई विल, मैं किसको ट्रैवर्स करूँगा ज़रा गैस करें. तो जो मेरे पास क्या है कि स्टैक के टॉप के ऊपर पड़ा है उसी को मैं ट्रैवर्स करूँगा. देन आई विल ट्रैवर्स द डी नोड, एंड there is no children of D, so the increment in stack will not happen. So then I will traverse the E node. So I will mark the red color over here, and there is no children of E node, and the size of the number of total nodes present in this stack will be 1. So at next level I will pop the C node, then the children of this node I will push these two nodes over here. Just look at the arrangement of these nodes. So जब मैं पुट करता हूँ, इनको पुश करता हूँ, तो वो अरेंजमेंट बड़ी इंपॉर्टेंट है. Then I will pop this nodes F and I will check whether it is a goal or not. Then there is only G node, सो G नोड को मैं क्या करूँगा, पॉप करूँगा, तो here is the resultant of traversing a tree which have the branching factor 2 and the depth is also 2. So the memory requirement for this tree for traversing this tree by using depth first search is 3. So इसी एग्जांपल के लिए जो था हमारे पास for BFS the memory requirement was 4. So look at the difference between the memory difference between DFS and BFS. So यहाँ पे देखें कि एक चीज़ important है, just look at where the highest memory requirement. So when I traverse this node B, then the memory requirement is highest. Our number of element in present in stack is highest. So ये कब हुआ, जब मैं लीफ नोड से एक नोड पहले फर्स्ट ब्रांच की लीफ नोड से पहले वाली जो नोड है उसको ट्रैवर्स करता हूँ, तो वो फिर नोड में उस लोकेशन में कौन कौन से एलिमेंट हैं, वो ये हमारे पास C है, E है और D है. इसको ज़रा मद्देनज़र रखिएगा, ये बड़ा ही आगे जाके आपके काम आएगा. So just look at another example of tree. I will solve this tree, I will traverse this tree by using depth first search and check the memory requirement for DFS for this tree. We also used this tree in previous video for BFS, and the memory requirement for BFS was 8. So now here is the stack which have the size is 4. Initially this stack is empty. I will push the node A into the stack, then I will pop the value of from this node and check whether it is a goal or not. If it is not a goal, then I will mark the red color over here, and the children of this node C and B, I will put these two nodes into the stack. Then I will traverse the B node, and the children of this B node D and E, I will put these two nodes into the stack. Then I will traverse the D, and the children of this node H and I will push these two nodes into the stack. So look at the arrangement, how I am placing these the children element into the stack. I put first I will push the this node, and then I push this node after the this node. And in the same way पहले मैंने इसको E को डाला, फिर इसको D के अंदर D को पुश किया. In the same way I push the I node, then I push the H node. So then मैं गेस करें ज़रा किसको मैं ट्रैवर्स करूँगा. So मैं ट्रैवर्स करूँगा H को, क्योंकि वो मेरे पास क्या है, स्टैक के हाईएस्ट ऊपर टॉप लोकेशन पे पड़ा हुआ है. So I will pop the node from pop the value of pop the value from stack which is the H node, and there is no children. I will traverse and write over here. So there is no increment in stack. Then I will pop the next value which is I and check whether it is a goal or not. Then I will pop the next value from the stack which is E and check whether it is a goal or not. If it is not goal, I will put over here, and the children of this node I will push the child nodes into the stack. So just look at the arrangement. First मैंने K को enter किया, then मैंने J को. Then I will pop the next value and which is J. Then I will pop the next value K, and then I will pop the next value C. So J, K have no child nodes, so there is no increment though in stack. Then I will pop the C node and mark the red color over here, and the children of this node I will put these two nodes into this stack. So then I will traverse the F node which have two children. Then I will pop the node L, and then I will pop the node M, and then mark the color of red over here. There is no child for M and L. then I will pop the node G. G have 2 children, so I will push these 2 nodes and look at the arrangement. पहले मैंने O को push किया, then मैंने N को किया. Then I will pop the node N. At last I will pop the node O. So here is the resultant. At the end the stack will be empty, so the visited node pattern is here. So just look at the memory size, memory requirement for to traverse this tree by using depth first search. A tree which have the branching factor 2 and depth is 3, the memory requirement is 4, but when we traverse this tree in previous lecture by using BFS technique, the memory requirement was 8. So just इसका ज़रा देखें कि इसकी रिक्वायरमेंट क्या है, मेमोरी रिक्वायरमेंट क्या है, कम है BFS के निस्बत. बट ये कब अकर हुआ, जब 4 की वैल्यू कब आई है, when I traverse this node D, एक लीफ नोड से एक नोड पहले. बट और एक और चीज़ इंपॉर्टेंट यहाँ पे देखने वाली वो ये है कि इस लोकेशन पे कौन कौन सी नोड्स जो हैं वो हमारे पास स्टैक के अंदर मौजूद थी. At this location the memory requirement is higher, and just look at the node values. So C, E, I and H. तो इस लोकेशन पे जाके क्या है, मेरे पास क्या है, मैक्सिमम वैल्यू आई है कब, जब लीफ नोड से एक नोड पहले फर्स्ट ब्रांच में, और उसमें उस दौरान कौन कौन सी नोड्स थी हमने इसको देखा. So here is another example of a tree which have the branching factor